Hello everyone, my name is Santosh Kumar and a warm welcome to everyone who have tuned in for today's talk on serverless computing using Knative. I work for Wipro as a senior software engineer with 8 plus years of experience and I'm passionate about learning new technologies. I strongly believe community plays an important role in your career because you interact with many people from different parts of the world who are doing different things and which is interesting, and you try to learn from many people around the community, and that really helps you to grow in your career. I'm also trying to learn myself in areas like DevOps and cloud computing. Agenda for today's discussion: we will try to define what is serverless computing and its evolution, different types of open source projects that helps to achieve it, but our main prime focus will be using Knative, which is an open source project managed and maintained by CNCF, and also we are going to try and see different types of managed serverless computing options provided by different cloud vendors that internally uses Knative. Finally, we are going to end with some useful resources that you can refer, and you can also try to contribute on projects like Knative that can add some value to the existing contributions. So what is serverless computing? Serverless architectures are increasing in popularity every day since the first offering was released, AWS Lambda, in 2015. Serverless architectures have been around for a couple of years already, and yet there are numerous challenges that we need to solve. But what exactly is serverless? Well, I can tell you one thing: serverless doesn't mean less servers or no servers. In fact, serverless is all about hiding the fact that your applications are running on a server. So, how is that possible? Well, it does this by using a concept called dynamic infrastructure. Dynamic infrastructure is a concept whereby underlying hardware and software can respond dynamically and more efficiently to the changing levels of the demand. The key word in this sentence is demand, because we want our infrastructure to react to the incoming traffic and scale applications up and down based on your needs. In fact, this system should also allow us to even scale down to zero. So no incoming traffic means there is no need for application to be running and no cost are incurred. That's nice, right? But how can we put this into practice? Well, to do that, we would first have to look at an example of modern cloud infrastructure. Typically, we start with bare metal, some hardware resources like CPU, RAM, hard drives, and so on that resides in a data center. However, using bare metal machines is not very efficient, so we need to take advantage of the fact that one machine can run more than one application, and so virtual machines takes the spotlight. Virtual machines allow us to run bare metal hardware in a multi-tenanted fashion, allowing multiple applications to run on a single machine. And still, this is not enough. Virtual machines are still very expensive to run due to the operating system that needs to be running on top of them. That's why containers make their way into our tech stack. Containers allow us to more efficiently use virtual machines operating system, but still maintain a high level of isolation between the applications. This is interesting, but what's the connection between this and serverless? Well, here comes the fun part. To make an application deployed on a container, there are multiple processes that needs to be in place. We are going to start with something called as provisioning. Provisioning is the process of creating virtual machines and related infrastructures in an automated fashion. Then we have something called as orchestration, which helps you to deploy our application in a specific way. We have something called as scheduling. Scheduling is the process of determining where we should run your application, because some virtual machines are utilized more than the others. So we need to make sure that we have a balanced usage of VMs. Then we have something called as network automation, which helps your application to need to communicate between themselves or even with the outside world. We have something called as network segmentation, which is nothing but the opposite of network automation. We need to make sure our applications are only allowed to talk with the ones they need to. And then we dive into runtime processes like service configuration, where application need to be configured through a process called a service configuration. We have something called a service discovery, which tells us where a specific instance of our application is running, followed by service registry, which works in conjunction with service discovery by telling us how to connect to specific instances that we're looking for. Then we have something called as observability. Our application needs to be monitored and we should be alerted if something goes wrong and why it is going wrong. Finally, we also have a concept called traffic shaping, something we just want part of our users to experience whenever a new version of our application is deployed or released. When we get full confidence that everything is stable, we can route the entire traffic to the new instance. In a typical setup, all these processes and concepts are handled in a semi-automatic fashion. Only a few of them can be solved through an automatic process. Whereas in serverless architecture, we typically have a platform that can handle all these concepts. Our goal is pretty straightforward. We have application represented by a bunch of code, and we don't worry about all these aspects. All we need is to provision the serverless platform with our code, and then it should take care of all these previously mentioned concerns. Now, this may sound familiar to you in the form of functions as a service, or shortly said as FaaS. This is exactly what FaaS platform does. It takes our code, handles all the dynamic infrastructure concerns. However, there are few things that you should take into consideration. FaaS platforms are cloud provider specific. AWS has Lambda, Azure has functions, and so on. Also, functions are by default single-threaded process unless we explicitly create a new thread as part of our application. The functions cannot act as a multi-threaded application. Finally, functions are short-lived. Most of the cloud providers have restrictions over the duration that a function can run, which is usually a matter of minutes. That's why serverless is not same as FaaS. In fact, you can consider functions as a service as a subdivision of serverless. And let me explain why. So I said that FaaS are cloud provider specific. Well, serverless platforms are typically cloud provider agnostic. We don't really care if we are using Google Cloud or Pivotal Cloud Foundry as long as our application is in a serverless manner. Then we have the multi-threaded aspect. Serverless is all about bringing an abstraction over the underlying infrastructure that our applications are running. So there should be nothing stopping us from running the multi-threaded process such as HTTP server. Finally, time is also not all a problem for us. We are completely used to having a long running process or long running application like a nightly job or HTTP server that can run for days or even months without interruption. Now let's look at how a serverless computing can be achieved using Knative. Knative is an open source project which was initially developed by Google and few other companies, and now it is part of CNCF. If we can take a look at the definition of Knative on the knative.dev website, we find that Knative is a Kubernetes-based platform capable of deploying and managing modern serverless workloads. Sometimes you may hear of Knative as a platform for building platforms. In fact, a lot of great products have been built based on Knative, which we will discover in our upcoming slides. But first, let's take a look at Knative architecture. I just mentioned that Knative is a Kubernetes-based platform. So in order to run a Knative, we need a perfectly running Kubernetes cluster. The Kubernetes clusters will give you the orchestration layer, perfectly adaptable for deploying and managing the containers. Then we have the network layer, typically represented by Istio. We can use other tools for networking also. Say for example, we have Ambassador, Control, Glue, Kong, and Courier, but the most frequently selected options is Istio. Finally, we have the serverless layer represented by Knative. This layer binds everything together, abstracting away the kind of underlying infrastructure to our application. Knative was originally comprised of three components, which is Knative Serving, Knative Eventing, and Pipeline. Knative Serving can be used to deploy and manage the HTTP workloads in a serverless manner, such as web applications. Knative Eventing enables a flavor of event-driven architectures by deploying serverless workloads that reacts based on incoming events. Now the third Knative component, which is Knative Pipeline. Knative Pipeline was a kind of a build tool that allows you to create the CI/CD pipeline systems capable of easily building, testing, and deploying our code across the cloud provider. However, Knative Pipeline has evolved to a project called as Tekton, and it is no longer part of Knative component. We will mainly focus on Knative Serving as part of this session. That means I need to be comfortable working with Kubernetes resources and understand some of its advanced topics such as custom resource definitions. Let's start preparing our demo environment by setting up few Knative resources that will be required for running a simple web application to demonstrate scale to zero functionality using Knative. Then we also need to inject the networking layer represented by Istio. If you'd like to follow along, you can refer my GitHub repo all you need to have is a Kubernetes cluster up and running. If you don't have a Kubernetes cluster, try not to worry. It will be just fine if you can install a Docker desktop on your local machine, which is same in my case. The Docker desktop comes with an inbuilt Kubernetes cluster. The GitHub repo, you will find two folders: install serving and Istio components, Docker files, and a README file as well. The README file contains all the commands I will be running throughout this demo, so you can easily follow along, whereas the other folder contains the YAML files to install Knative and Istio components. Finally, the Docker folder contains the Docker file and HTML files. First, we are going to install serving component into a new namespace called serving using the command kubectl create namespace serving. As I already have the namespace created in my case, so let's verify whether the namespace is present or not using the command kubectl get namespaces. As you can see, I already have the namespace created. So let's head over to the next step. Next, we have to deploy a bunch of resources to that namespace. In fact, there are so many resources that the file is almost 3000 lines long. To deploy the resources, we are going to use kubectl apply command. In the interest of time, I have my setup ready, so I will just verify if everything is in place. So let's install and verify serving component by running the command kubectl apply -f serving components.yaml file. You can find this YAML file inside the install serving and Istio component folder in my Git repo. So now that the serving component is installed, let's verify if the components is installed properly. So to do that, we say kubectl get parts -n serving. Yeah, these are the components of serving, which is the activator, autoscaler, controller, and we can see everything is installed properly and everything is up and running. Now that the serving component is installed and the namespace is created, now we can proceed with installing the Istio components. To deploy Istio to our Kubernetes cluster, we need to install Istio to our system. Now that Istio is installed in my system is already, let's verify it using the command Yeah, you can see that my system is already installed with Istio data plane and control plane. Next, we need to provide some configuration so that Istio can be integrated with Knative, which we do by applying the changes present in the Istio resources.yaml file using the command kubectl apply -f Istio resources.yaml. And you can find this file as well in this folder. So you can see the Istio components is also installed, and that's it. We should now have a perfectly running Istio setup integrated with Knative so that it can handle serverless workloads and see the scale to zero functionality in action. Now, in order to deploy our application, we basically have to write a simple YAML file instructing Knative on how to handle the application. As you can see in my example, we have a YAML file where we tell Knative to deploy a particular container image as given here. Now let's apply these changes so that it can create this service using the command kubectl apply -f knative service.yaml. We successfully created our service. Now it's time to update the etc/host file with our domain name. You can see this is going to be our domain name. I have updated in the etc/host file. Now let's copy the URL of our application and paste it in the browser, and we can see if our application is running or not. To do that, I use the Knative utility kn service list, which will list all the service that is created, as we have one of the service which is created, and this is the URL for the service. Let's copy this, go to a new browser and paste the URL and see if our application is coming up. Yes, there you go. You can see our application up and running. Now that the application is running, let's check how Knative scales our application up and down based on the demand. To do that, let's watch the pods. As you can see, we have 3 pods running, and over a period of time, if we have no incoming traffic, it will scale down to 0. Let's wait for some time. Yes, you can see that the pods are getting terminated. It will scale down to 0 slowly, one by one. Yeah, it scaled down to 2 from 3, then slowly it scales down to 0. So now we don't have any pods running. So now let's pump some traffic and see if it scales up again. So let's refresh again. Yes, you can see that our pods are getting created again. So that's scaling up again, and this finishes our demo. Let's continue our discussion back. As I mentioned earlier, that there are some great products out there that already take advantage of Knative. In fact, you can already get a flavor of Knative as a service which is offered by multiple cloud providers. There are different offerings such as Gartner, Google Cloud run by Google, IBM Cloud Code Engine, Pivotal Function Service, and Red Hat OpenShift Serverless, and Trigger Mesh Cloud. All these great products are using Knative under the hood to power your applications. What about the alternatives? There must be some tools out there similar to Knative, right? And indeed there are. If you're really interested in serverless world, then you should consider exploring all these. OpenWhisk from Apache, OpenFast, Fission, and Kubeless. Each one of these has pros and cons. You should definitely take a look at and pick the best option that suits your application. Now let's look at some of the important resources that will help you to understand more about the concept of Knative. First one is the website which I would suggest you to have a look at. It's knative.dev. It's the original documentation website. They have a lot of things here. Some of them are the tutorials where you can try how to install each and every component of Knative, and you can also play around by using the independent components. You can install serving alone, and you can try how to achieve or how to see the functionality of scale to 0. Also, you can try installing eventing separately and see how to implement eventing using Knative eventing component. So this particular website is quite straightforward to try multiple things, and you also have documentation to understand more about each and every component with some good diagrams, also some references. This is something that I will strongly recommend to go through. The next one is, if you're looking for some good textbook around Knative, VMware is providing you a free ebook which is called as Knative in Action, and it's free to download, and the book is really good with some good diagrams. You can also refer this book to get more insight about Knative. And if you're looking for some live or some pre-recorded videos, VMware is also doing something called as enlightening video sessions in YouTube, and they bring in more people who work on multiple areas. One of them is Carlos Santana. He is part of Knative contributor, so he has contributed to Knative project a lot. So you can take a look at this video, and you can understand more about Knative by by going through this kind of videos by the own creators. I think these three resources might be really good for you to follow, and you can also try to contribute to Knative projects if you really want to add some value, and that will really help uh, the community as well. And as a technology, you can also gain a lot of understanding about things like serverless computing and Knative. I hope you found this session useful. Please feel free to connect me over the LinkedIn if you have any doubts or if you want to share some suggestion. And thanks for Kubernetes Community Day Pakistan team for giving me this wonderful opportunity to share my knowledge. Thanks everyone.